Hello guys, welcome back to another OrCAD X keyboard tutorial video. My name is Adam, and in this video we are going to set up the constraints so that we can be ready to start doing the layout on our PCB. Now, constraining a design can either be sort of something that you do while you already start on the layout, but in general, in my opinion, the best practice is to do your constraints ahead of time so that when you are doing your layout, you don't have any surprises. So when you're doing your constraints, you kind of want to have an idea of all of the constraints for your design or how your design will behave while you are doing the layout. And so you're not caught by surprise by, for example, a wrong via showing up out of nowhere or some strange line width, right? That doesn't mean that you can't adjust your constraints as you go, right? Maybe when you're doing your fan out, you realize that your trace width or your vias are too large and you have no way of completing the fan out for your board without maybe using a smaller trace width. And that's okay. So what we're going to do in this video is set up the constraints for mostly this section of the design, right? As this is kind of the most touchy section of the design. And this is just to make sure that our board is manufacturable, to make sure that we are not not going to be placing traces too close together, making sure that we're using the right via throughout our design, and making sure that our power traces also have a slightly thicker trace width. So to start our constraints, we're going to go into Tools and select Constraint Manager. And in here, we can either start with the physical section or the spacing section. Now by default, the electrical worksheet is what actually is opened up, but the electrical worksheet is traditionally for high-speed routing, and our board is really quite low speed, so we won't need to worry about things like impedance matching or propagation delays for this board. Maybe in a future board we will do something a little more complex. All right, so in physical we have the constraint set section, which is where we kind of define a rule, and the net section, which is where we define where those rules apply to, right? Which nets we want this rule to be followed by. Okay, so if we look in our net section, we can see that we have a bunch of different nets, and they're all more or less just kind of, hanging out alone as individual nets. So what we want to do is to start to organize them into what we call net groups. So to do that, what you can do is highlight a couple different nets and then do a right click, create net group. And in this case, I've selected a couple power nets, so we'll call this our power net group. And once we create that grouping, even if we jump into the net section for spacing, we should still see that same grouping. So the net groupings exist between different worksheets. And we're going to use that to our advantage because we want to, assign specific rules to all of our power nets and then different rules to, for example, all of our signal nets, and make sure that we can, set different rules without having to redo our work. Okay, let's go back to the physical section. And for example, all of our column and all of our row nets are what we would call signal nets. So we'll add those to a group called signal. If we keep scrolling through here, we can see that we have, for example, USB D, P, and DM. These are, like digital signals, right? We have our serial clock and serial data for our I2C, read, write, some QSPICE signals. Let's just go ahead and select these. And I would treat these as regular digital signals as well. We have the data lines for our LCD, an enable line, LED data. These would all qualify as, again, signal nets. So let's go to the bottom here, right click, and we want to, in this case, add to net group, choose the signal net group and click OK. And then finally, we have this backlight. I believe I wanted this to be also a, technically the backlight, if we were working with a much bigger screen, for example, you might want to have a little bit of a thicker trace. But in this case, this LCD really does not use a lot of power, so we'll add this to the signal group as well. And our ground net, this is actually a power net, so we will add this to our power net group. All right, so we have a power net group and a signal net group. And now what we want to define is some rules for power nets in our design and signal nets in our design for, how small the minimum line width can be or how large the maximum line width can be. If I go into physical constraint sets and I go to all layers, right click on the default and say create physical C set, and we will call this our power constraint set. So for my power nets, I'm just going to pick I don't actually know what value I want to use right now, but let's just say, for example, we want to use 20 mils as our minimum line width. And let's say our maximum line width can be 100 mils. If you leave this as 0, that means there is no maximum and you can, use whatever line width you want, and it won't flag a DRC error. Now for power nets, I do want to also define a neck width. The reason for that is if we try to use this 20 mil width, and we can just see an example here, and use our route command from one of these nets. Oh, we actually have to assign it to the nets. Let me do that really quick. So nets, to power the power net group, I want to assign the power constraint set. So you'll see automatically it assigns that 20 mil width, 20 max width. But if we start to route one of these power nets now, right now we have this really thick trace, and it's not going to be, routed very easily to our microcontroller. So what we want to do is allow for a neck width, and let me just remove these colors. What we want to do is assign a neck width, which will allow us to use a thinner width for a short neck length. So in this case, what I want to use is if I click on this pin, I want to use the exact same width as this pin for my traces. If I look at this copper pad, I can see that it is 7.87 mils wide. So if I go into my constraint manager and I go to my physical constraint set and say that my neck for power, I want it to be 7.87 mils and with a max length of, let's say, 200 mils. Now, if I start routing from one of these power nets here, I will be using this regular 20 mil width until I get closer here. And then in this trace width section, I can set it to neck. And I will use this thinner width to adjust. And look at that. It will go really nicely into this pin while still maintaining a thicker trace width for our power delivery into the microcontroller. It's just a really easy way to set up your constraints in such a way that when you're routing power, you can use a thinner width, or even if you're routing a signal line, for example, underneath a BGA and need to use slightly thinner traces than what your normal constraint is, you can switch to that neck mode and use that for your routing. All right, so let's go back to Constraint Manager. Since we're not really worried about differential pairs, we'll skip that for now. The only thing we want to set up is the vias that we use in our design. Now, the default via, this is included in your installation, is just called via. If we start routing from one of these traces and double click, we can see that via gets placed and looks pretty good. If this via does not match your requirements, maybe you realize that, hey, if I use this exact via, I will not be able to fan out all of these connections. What you can do is if you go to Constraint Manager, in this via section, double click, you can then select a different via. So if I type in via here, I know that I have a couple different vias which I can use. I really like this via 26 pad stack, which I've created. So I'm going to set this for my default and also for my power and use that throughout my design. You can have multiple vias also selected for different constraints. And then when you're routing, you'll just have an option of, which via do you want to use to go from this top layer to bottom layer. or even if you're using micro vias, you can have multiple vias here. One via being, for example, from your top layer to the second layer to the third layer, a separate via. And you get this nice preview at the bottom here, which will show you, this via 26 goes from my top conductor layer to the bottom conductor layer. So click OK. I have via 26 defined. And now if I delete this and start routing again, this is my via 26. I believe the only difference here really is that it has a slightly smaller solder mask expansion around the via. Otherwise, nothing too crazy. Okay, so back to Constraint Manager. We've created a power constraint set. We also want to create a signal constraint set. Now be careful what you right click on when you're adding a new physical constraint set, because if I right click on power and select create constraint set, it's going to use these values for sort of the default values, and then you can change them. I like to always right click on default, create physical constraint set, and we're going to call this signal or sig. And here you can see that it's copied the values from default. So for my line width, I want to use 7.87 mils where possible. Max, let's leave that at 7.87. And for neck, I'm going to say we can go neck down to 6 mil width, again for a maximum length of 200 mils. And then because we copied it from the default constraint set, it's automatically copied over that via 26 for our vias that we can use. All right, so let's go into our net section here and just make sure that all of our signal nets are assigned the signal constraint set. And now when we start routing from any signal, for example, this SDA, let's make sure that this is set to auto. And let's just place a trace in a via. We can see that this trace here is 7.87 mils, and this via is my via 26. So everything is working as expected. That is pretty much good to go. Okay, the next thing we want to do is to set up our spacing in our design. So in Constraint Manager, if we go to the spacing section and look at our nets, again, we've already created all the net groupings in our design. Now the next thing we need to do is to set what spacing we want, from a signal net to any other object. If we want to set the spacing, for example, between a trace that is on the net, let's say that SDA net, and another part of a trace that is also an SDA net, then we would have to set same net spacing rules. Again, our net groups are already defined, but for same net spacing, I'm just going to leave this as is, just to make sure that, the constraint setup part of this video is not too long. So for spacing, let's go into our constraint set and look in our defaults. And I just want to add a new constraint set here and call this our power spacing, and another constraint set and call this our signal spacing. Now usually the spacing will either depend on one of two things. One is the voltages that you're working with, right? So if you have high voltages in your design, you want to make sure that your creepage and clearance is set accordingly, right? You don't want it to be arcing between traces. The second thing is if you had high-speed traces, high-speed signals on your design, you want to make sure that high-speed traces are not routed, too close to each other, and that you are not coupling. There's no coupling between those two traces enough to have crosstalk, for example. I guess the third is also your manufacturing sort of minimum spacing allowed, which could determine, for example, the price of the manufacturing of your board, or even whether or not it is manufacturable at all, depending on how advanced of technologies your fabricator can support. Okay, so for this design, I want to set my power spacing to be, let's say 10 mils. So power, in each of these columns, you can double click to expand, and you can see that you have line to line spacing, line to through pin, line to SMD pin. I want to say that these are 10 mils. I don't know exactly what this needs to be. I'm just using kind of a value that sounds about right for now. If you have different requirements for your own board that you're working on, or you're working with a manufacturer that allows for, slightly tighter spacing, by all means, feel free to set that in your design. But in my signal here, I'm also going to set this to 6 mil across the board. And we will say that this is good. And then just set my power to power and signal to signal. And then let's see what we get when we update our DRC. So right away, we can see that we have a couple DRCs in our design, because even with that 10 mil spacing, there are some pins in our design that, for example, are giving us a pin-to-pin spacing. And while normally if we had a spacing issue between, for example, these pins of a capacitor, in this case, we have spacing between pins of a component which we can't really move. So there's two things that we can do. One is we can adjust our spacing constraint such that it allows for this spacing. Or the second thing is we can create some region spacing rules which will override our regular spacing rule in certain regions on our board. Now, in general, I want to keep this 10 mil spacing for all of my power nets, but I will say that it is okay for, this section around my main microcontroller to allow for slightly smaller, pin-to-pin spacing or pin-to trace spacing, but only in this region. So to do that, in Constraint Manager, we will go in the spacing worksheet to Region, All Layers, right-click, and select Create Region. And we will call this our Power Dense Pin Region. Or, use whatever name is descriptive for you. And in this region, we will say that it is okay to have, let's just, across the board, set it to 6 mils. Okay, now how do we actually assign that region in our design? If we go into our layers and look at the top here, we have regions currently turned off. So make sure that you click on this region section to turn it on. And then you can toggle on or off, the regions by clicking on the column here. And let's just set it to a uniform color really quick. So we'll use that kind of pinkish reddish color that was set before. Then we're going to go into our shape command. We'll select a rectangle, and then we want to set the shape use to constraint region and the layer to be on all layers. And then using our grid, let's set it to a 510 grid. Ooh, and we can turn that off. We just need to draw a square right around this microcontroller. And I forgot to set the actual rule set. So when you're in the command, you can set which rule set you want to set it to. So power dense pin, or after the fact, you can select the region, go to properties, rule set, and select power dense pin. And when we do that, you'll notice that right away, all of those DRCs have disappeared. We want to do the same thing in this section here. So it's okay to have the same constraint region drawn in a couple different areas in your board. Totally fine. So we'll have that there. Let's just check the properties. So this is the power dense pin, correct. And we need another one here. So constraint region, all power dense pin in this section right here. So now if we were to update our DRCs, you would notice that hopefully these DRC errors disappear for us as well. So let's go to Constraint Manager. I want to update the DRCs in my design. And Okay, so let's go ahead and update our DRCs. Click this refresh here, and it's up to date. And we only have 3 DRCs left. And you can see that these are just our package to keep in spacings that we have for, these different connectors here, as well as this mounting hole. But again, nothing to worry about. Maybe if we need to, we can move this a little bit over. There we go. All right. So now that we've added these regions, we can also use regions to do one more thing, which is to automatically adjust the trace width for these, power nets, so that we don't have to switch it to neck mode every time. So to do that, in the Constraint Manager under the Physical section, we also have a region. And in this power dense pin region, we can say that the minimum line width is 7.87 mils. And the neck, we can set it to 7.87 as well if we need to, but not a big deal. What this will do is when we're routing one of these power traces, even if we're set to auto and we start routing, and maybe we get into this, section here, it will automatically switch over to that 7.87 mil trace. And then we can easily connect it to whichever pin it needs to go without having to fiddle around with this trace selection. There we go. Excuse me, with the trace width option in our properties. So, alrighty, I believe our constraints are more or less done at this point. I could, go into much more detail about all of these constraints. We could set up manufacturing constraints, 3D constraints. How much effort you put into your constraints will really depend on how complex your design is and how easy it is for you to make a mistake. I do recommend at minimum always setting physical and spacing constraints for every net in your design, but things like manufacturing constraints, same net spacing, 3D constraints, kind of decide how much effort you want to put into that, or how much you trust your own judgment and eyes to catch mistakes, or maybe your manufacturer, maybe that they are able to catch some mistakes as well. So we'll finish this video here. Thank you guys for watching this part of the video where we talked all about setting up the constraints in our design. In the next video, we will finally start routing because we have all the constraint sets. All that's left to do is to use the route command to route our design, and yeah, we're good to go. So thank you for watching. Hope you guys enjoyed this video. If you have any questions, comments, or concerns, please leave a comment below and we'll try to answer it as soon as possible. If you want to follow along with this video, go ahead and download the OrCAD X Keyboard Video Series 5 constraints-done.brd, and then you can follow along and start routing the board just like I will in the next video. So yeah, see you guys in the next video. Thanks for watching. Bye-bye.